So hi everyone. Thank you for joining me today. Today I'm going to demonstrate how Foreman can simplify provisioning CentOS in your infrastructure. And this is my second time here in CentOS, and it's great to be back. Last year, one of my colleagues, Shim, introduced Foreman's capabilities, providing an overall overview of the project. And this year, I'm excited to take things a step further by diving into provisioning workflows and showing you a live demo in action. So whether if you're managing a small-scale environment or you're handling large-scale developments, Foreman offers powerful tools to simplify and automate your provisioning process, making your work easier and more efficient. Okay, so hi again, my name is Nofar, and I've been working in Red Hat for almost 3 years now on the Foreman team. My primary focus is on provisioning and its various aspects. And I'm also maintainer of the Foreman Ansible plugin, which enables seamless integration of configuration management into Foreman. And in addition, I moderate the Foreman community demos, which are being held every 3 weeks, where we share the latest developments with our communities and we foster knowledge sharing and collaboration. Okay, so a short agenda for today. We'll have an introduction, what is Foreman, then we'll talk about some of its core features, then we'll explain what is provisioning with Foreman, how it works. Then I'll try to convince you why to automate CentOS provisioning with Foreman. We'll have a live demo, and then we'll talk about recent features we've been working on, like Secure Boot and IPv6 support, the end questions and answers. Okay, so what is Foreman? Foreman is an open source, web-based system for provisioning and managing your servers. Basically, it's the perfect tool to manage your servers because it has so many powerful features, which we will cover in the presentation. It supports a wide range of operating systems, including CentOS. It's centralized management for all of your servers. It automates your provisioning task, reducing manual efforts, and it improves consistency and reduces errors in deployment because everything is automated. Okay, so some of the Foreman features, we have the provisioning, configuration, and monitoring. So for the provisioning, we have the bare metal. We support some virtual servers. We'll cover that next, and some cloud instances. For the configuration, we have plugins for Puppet, Salt, and Ansible. You can automate everything from Foreman. And for the monitoring, we have the facts, reports, statuses, dashboards, etc. Okay, so if we're talking about provisioning, these are basically all the components that we cover for Foreman. So we talked about bare metals and VMs. We also have the PXE booting, the grep2, BIOS, UEFI. Everything is supported from Foreman. We have the subnets and domains can be managed from Foreman. Same goes for DHCP and DNS services. Multiple operating system support and the templating system and registration. And the list of the computer resources and profiles supported by Foreman, as you can see. Okay, talking a little bit about configuration. So we already mentioned Puppet, Ansible, and Salt. We also have host groups, which is basically a set of hosts that share the same configuration. It can be managed via host groups. We also have the parameters, which is basically the same idea. You can define the parameters on the host groups, on the host, on basically each component that Foreman has. So it can be DHCP, it can be DNS. Each one of them has their own parameters. Authorization, which means that you will have multiple users in Foreman and not all users can perform the same actions. So for example, some user may have permissions to execute Ansible roles and to see them and to edit them, update them, and the other user may not. It all depends on your needs. The last one is organization and locations, which also I'll cover in the demo, but basically it means that you can divide your Foreman into smaller pieces if you don't want to control all your servers in one place. That's possible via organizations and locations. And last one is configuration and monitoring. So we have the facts, the reports, the statuses, the dashboards. I'll show a little bit about it in my demo, but basically it's some visual tools from Foreman where you can monitor the statuses of your server. Yeah, and some plugins that Foreman have, for example, remote execution is a plugin that works together with Smart Proxy, also something I'll cover up next. We'll have the discovery. So Foreman Discovery is a tool that allows for the automatic dedication and registration of physical hosts in Foreman. So that means if you want to discover a host in your network, Foreman can do it for you automatically. Yeah, and boot disk, webhooks, etc. Okay, so here's an overview of Foreman architecture to give you a better idea of its integration points. At its core, there's the Foreman server, which orchestrate provisioning tasks. Compute resources integrate with virtualization platforms, and all of this works together to manage your host lifecycle. We have the smart proxies that extend Foreman's capabilities to remote networks, handling tasks like PXE booting and Ansible jobs. And I would say that smart proxies are mostly useful in large distributed setups where Foreman needs to manage services across multiple locations. So we'll dive more into it in the next slide. So as I mentioned, using a smart proxy in Foreman provides numerous advantages, including improved scalability by distributing tasks such as DHCP, DNS, TFTP, and config management tools like Puppet or Ansible across multiple proxies. It reduces the loads from the main server, basically, and it enables network segmentation, allowing Foreman to manage remote or isolated systems without requiring direct communication with the central server. And the smart proxies also enhance performance by reducing latency and providing faster response time, especially for provisioning and PXE booting. Okay, so how does Foreman handle the provisioning? So first off, we need to create a host in Foreman. And we'll define all the specification for this host. So that includes which operating system we want, some network settings, etc. Then we have the provisioning templates, which is predefined templates to automate the setup. For example, we can use the Kickstart or Precede. OS installation, Foreman will take care of installing the operating system automatically from the templates provided by Foreman. Configuration management, after the host is all set up and running, we'll have the Ansible or Puppet jobs that will be post-installation configuration. And that's it. After that, the automatic setup, once configured, Foreman will handle networking, partitions, and installation for you. Okay, so if I haven't convinced you already, why to choose Foreman for CentOS provisioning? So as I mentioned, it centralizes your management tasks, making automation and consistency effortless. With built-in integration for PXE boot and Kickstart templates and more, you can deploy a system reliably. And plus, it scales beautifully across physical, virtual, and cloud environments. Okay. Yes, this is time for the live demo. Okay, sorry about that. Can you help me? Where's the settings? Right there. Oh, left. This one? Yep. Okay. I don't know what to... Wait, maybe. Okay. Sorry for this. The demo I need to mirror. Okay, great. Okay. So I will log in into my Foreman server. This is how my dashboard looks like if we were talking about monitoring. Yeah. Okay, I have an error for some reason. So let's make it disappear. You can remove some of the dashboards if they're less relevant for you. Just wanted to show you that. Didn't expect any errors. So let's ignore that. Okay, so what do I need to do the Foreman provisioning? So first of all, I need to create a host, but to create a host, I need to decide which operating system I want to install. I will use the search bar here. For this demo, we're going to choose the CentOS Streamline. And this is the operating system I already have defined in Foreman with a major version. And architecture, the partition table, I'm going to use the Kickstart default provided by Foreman. The installation media, that's also something I already have defined. Just the two of them, the rest of them I will define by myself. So this is the installation media. And this is basically just a link from where to download the operating system. Okay, going back to the operating system, you can see here the templates that I have for it. For example, for the provisioning template, I'm going to use the Kickstart default. If I want to use grub2, I have the PXE grub2 template here defined, and that's it. Here are the parameters. I don't have anything, but I can add if I want. Okay, so this is the operating system I'm going to use. After that, I want to check that I have all the services needed up and running. For that, first of all, I will create a new organization. Let's call it CentOS Connect. Okay. Here I could have defined some of the things, but I will do it after. Okay, so I was going to show you the smart proxy. Smart proxy is not created. Let's create one. No, you know what? Instead, let me use the existing smart proxy I already have. The reason I want to do that is because I already have the services up and running. So for example, you can see I have DHCP, I have Ansible, I have DNS, and if you ask yourself how to do that by yourself, there is a tool called the Foreman installer, which is just a command line tool. You run the commands and with the values that you want, for example, the DHCP server address that you want in DNS, and Foreman will set everything up for you. So I already have this set up, which is great. So I'm going to use this existing smart proxy, and I just need to add the new organization I created for it, so it will be accessible. Okay. Now I will go back to the CentOS Connect, and I have the smart proxy up and running. Great. This is the first step. After that, I need to create my host. So I will go to All Hosts, click on Create New Host. You can see here the name is a random name. Let's give it CentOS Connect Demo. And it deploys on bare metal. No Ansible roles I want to give so far. Let's set up the operating system, the architecture. We said we want to choose the Streamline version. Media. Okay, now I don't have any medias available. This one I forgot, so I will go here. Okay, it's not accessible through my CentOS demo organization. Right? Okay, so let's fix that. Okay, I added the organization. I wanted to create a new one, so I will have the opportunity to set up everything from scratch, but it costs some issues. Okay, so starting again. Let's just keep it, the name it automatically originated for me, and okay, now I gave it the partition table, Kickstart default, and the pixel loader want to choose is the grub2 UEFI. Okay, I'm going to generate a password, and now I will click on resolve to see that all the provisioning templates are correct. Okay, for the interface, let's leave it for now. And let's go to the Virt manager to create the host from there. I'm going to create a new virtual machine. CentOS streamline. Let's give it a name. After that, I will use it for my host. And the only thing I need to take care of here is that firmware should be UEFI. And I want it to boot from network. Okay, that's great. Now I needed to do that because I need to use the MAC address here. So let's change the host name so they will be the same. And if I go here to the interface, I need to use the same MAC address. Okay, so one thing I didn't do is to take care of the domains. Okay, so let's create a new domain. Okay, I'll go here first. And let's give it CentOS Connect, a new domain. And I need to choose the DNS proxy. Right now, I only have one smart proxy, so I will choose it. But if I had multiple smart proxies, I could have picked one. Okay, let's see what else I didn't do. Subnet. Right. So let's create a new subnet. Name of the subnet will be CentOS Connect. Protocol IPv4, the network address will be this one, network prefix 24, network mask generated automatically. And I will give it the gateway, the DNS. For IPAM, I would like to choose DHCP. I want to manage DHCP service here. Start of range, end of range. If you have any questions about the fields, please let me know. Yeah, and everything is okay here. For the remote execution, this is the smart proxy. I chose the localhost that I'm using. The domain we just created, CentOS.connect domain. DHCP proxy, everything is going to be under localhost, but as I mentioned, you can have multiple proxies and then you can play with it. And no parameters and location organizations already been taken care of. Okay, let's click submit. Okay. So I need to refresh the page, unfortunately, because I just created these two. So again, third time's a charm. I give it the name, you're already familiar with it, which is great. Again, I'm going to set up all these fields. This is a great example why you should use host groups, because if I would have chosen to just create a host group, I would have all these fields already set up, and I didn't have to do it multiple times. Grab two, UEFI, great. Okay, everything is good. Now just the interface, and that's it. Okay, the MAC address. Now I have the domain we just created and the subnet. Oh, now I see I've misspelled it. Never mind. And the IPv4 address was being taken care of from the DHCP service, which is great. For parameters, I just want to add update package parameter. Update packages. It's going to be Boolean. I'm going to set it to false. The reason I do that is to make the installation process faster. Okay, I click submit to create a host. Let's give it a second.
You're doing the whole demo with only one hand. Impressive part.
Yeah, but I think my computer doesn't like it. He needs both ends, maybe. Okay, so let's see what's going on. Let's debug it. Everything looks good. No, but like I did it on purpose. Okay, so you know what? I'm going to use the host groups. Let's do it one more time using host groups, and hopefully that will work. Basically, in the end of the demo, I just wanted to show everyone that it works. So, worst case scenario, it won't work, but you all have to believe me. Yeah, we're building trust together. It's okay. Okay, so this is a host group. I'm going to do the setup from here. And then I'm going to try to create a host again using this host group, but everything will be like already configured. So it will just take a sec. And if you're familiar with the fields, it's because we already set them up from the host page. Thanks. Oh, wow, James, good catch. You too? Why? Because there's always things going wrong. Okay. Okay. So update packages. Sorry. Let's see if it will create a host group. Yeah, the host group successfully created. My host is not created yet. I want to debug it, so. Okay, create a host. I'm choosing the host group, and you can see all fields already been set up for me. The only thing I need to take care of it is the interface. And no, the virtual machine has not started yet. No, this one I need to. Well, I need to click on begin installation basically, but yeah, Foreman will take care of the rest. And you see, I already have the domain, the subnet, and the IP address. The only thing that is not correct is the host name. Now that I think about it, I could have done something else, but never mind. Let's see if that would work. Okay, it looks like it's all okay. Well, my first host was created. It took a while. I will cancel this one. I'm not sure why, what happened here, but I can show you the fields here in the details. You can see, for example, the provisioning templates. You can see the domain, stuff like that. Everything is set up correct. I have no idea why it took so long, but let's go back to the Libvirt machine. That's it. I'm going to click on begin installation. And hopefully the grab menu will load up. Yeah, okay, so this is PXE booting, so it starts PXE over IPv4. And yeah, let's give it the Kickstart default grab to PXE grab 2. It supports iPXE, not for everything, but yeah, we support iPXE. Okay, so I now remember I didn't take care of the firewall before the demo, so let's see if that will work. No, let me do it for just a sec. Okay, I need to change to trusted, the interface. Okay. Okay, let's give it some time. I'll go back to my presentation and we'll get back to it later to see the results. To join again. Okay, good enough. I did a mistake. Okay, let's try it again. Maybe if I disconnect it for a second. Okay. Yeah, okay, so let's talk about recent advancement we've been working on. The first one is the Secure Boot implementation. We talked about Secure Boot today a little bit. Secure Boot helps you to ensure that the integrity during the provision process, that your operating system is signed by like authority that you trust. And we have Secure Boot supported on VMware and Libvirt compute resources in Foreman so far. And the second feature we've been working on is IPv6. Recently, we added support to help you provision your host in a pure IPv6 network using PXE. And for the full IPv compliant, the dual stack support is planned for the future release. So for the Secure Boot, from the user side, it's the easiest thing to do is to provision a host of the same operating system as your smart proxy. For example, we showed in the demo CentOS 9. So if you want to provision a new machine with Secure Boot enabled for the CentOS 9 operating system, you don't need to do anything basically from your side. But in case if you want to provision a different operating system, for example, Fedora, you will need to create the grub and the shim file by yourself, like basically to copy them from place you trust and to place them in a designated directory in Foreman, as shown in the picture below. And then what will happen is that Foreman will take care of creating a new directory for your specific host with the necessary boot files. So what happens like behind the scene is that the DHCP server will have to retrieve this grub and shim files from this specific location for the host you're creating. And I think that's it. So let's go back for a second to see the Libvirt machine. It looks like it's stuck. Okay, we can try to boot it again, and meanwhile we'll have the answers and questions. Yeah, so any questions?
Does it handle multiple releases at the same time? For example, I'm doing something like this myself, but I'm deploying Rocky and I'm deploying RHEL. But for Secure Boot, I have the issue that the PXE executable either signs for Rocky or for RHEL, but not for both.
Yeah, so like on the Foreman side, there's no problem with it. The only problem I can think of is from DHCP server. You will have to give it a different location for the shim and grub files. Yeah. So that could be tricky, unless if you have multiple DHCP servers, you can manage them like from Foreman with multiple smart proxies. But yeah, I can think of any other way to solve it.
And the other question is, does it support using HTTP or HTTPS to load the kernel and the initRD, or does it still use a TFTP?
Yeah, you can do both. I didn't show that, but when you choose the bootloader, for this demo, I chose the grub2 PXE UEFI. If you want, you can also use the HTTP or HTTPS for Secure Boot. Yeah, this is possible. No questions? Okay, great. Let's see one last time about the machine, because, okay, I see it is stuck somewhere. Unfortunately, I wanted it to do the whole provisioning process and then show you also how Ansible and Puppet can be executed on the machine. And fortunately, I wasn't so lucky, so, oh, maybe next demo. Okay, so upcoming events. We have a booth session in FOSDEM for the Foreman community. If you would like to join us, we'll be happy to see you there. We also have a designated room for Foreman talks in Config Management Camp. That's it. Thank you. These are all the contacts you need to contact Foreman and me. So thank you for your time.